Okay, today's lesson 4.5, using graphs to estimate values. What we're going to do is we're going to look at graphs and figure out different values based on the graphs. So what we have here on the left-hand side is we have a graph population and monthly water usage. So the bigger the population, the more water they're going to use. So let's look at the first question. Well, we'll look at the graph, I guess. Population along the bottom here, water usage is along the top. Now, if you look here, 1 ml is 1 million liters, right? So because the number is so big, we have to use these abbreviations. So estimate the monthly water usage for a population of 150,000 people. So population down here, what we do is we look for where 150,000 is, right about here. We draw a line straight up until we hit the red line, and then we go straight across until we get our value over here. So here's, you can see how we just drew in that line. So you have to, it's estimating, right? So estimate, so you're not gonna have an exact answer. So I figure about 1,100. So if you had maybe 1,200, some of you had maybe like 1,050, those are all acceptable answers, okay? Estimate the population when the monthly water usage is 1,400. So now we're going to go backwards. So we're going to look up the water usage here, find 1,400, go across until we hit the red line, and then we go down, bang, and then we can figure out what it is. So about 185,000. Okay. What about if you had to predict the water usage for 250,000 people? Well, that is, well, you can see there's 100,000, there's 200,000, like 250 would be over here, so somewhere off the graph. And we're going to talk about that in a minute of how to deal with stuff that's off the graph like that, okay? So flip the second page. Let's look at, the graph shows how the distance traveled by a car changes over a 4-hour period. So what we have here is distance and time. Think about this, the longer you drive, the further you're going to go. Now, this is assuming that you're traveling at a constant speed, and that's not always the case. So we draw the graph, we plot it out, and then what we're going to do is we're going to find what is the distance traveled at 2.5 hours. So go here and go to 2.5 hours, draw your line straight up, and then go across, and you can see it's approximately 200 kilometers. Now, this is called interpolation, because what happens is we are looking at the data within the graph, right? The data is within the graph. If I ask for something like 5 or 6 hours, which is way over here, that data is not in the graph. So this is within the graph, and we can just estimate. And you could go backwards. For instance, I could say 300 kilometers, how long? So you go across 300 and then go down wherever it hits, right? So that's an estimation. Okay, now, and you can see the next, if you flip to the third page, this is the same thing we do. It's the same example, just different examples here. So 1.5 hours, right? We go up and then across. Yeah, we can see it's about 120. We could go backwards and say, okay, 300, go across and down. Yeah, you can see it's about 3.25 hours, right? That's all interpolation because it's within the graph. Okay, so the fourth page there, flip to it, you can see right away that now we're going to talk about, suppose the car maintains the same average speed, right? What we can do is we can then extend this line. We can extend this red line as far as we want to go, and we can extend our axis, our x here, which is time, and our y, which is distance, and we can extend it as far as we want to go. So now what we can do is, well, there's two questions here. So estimate the time it takes to travel 450. Well, 450 is on the graph, right? So 450, come across, right? Come across here, hit the red line, go down. You can see it's just over 5.5 hours. That's interpolation because it's within the graph. Now, what about if we want to know 7 hours, let's say. So let's say we want to go 7 hours. So 7 hours, 7 hours is not on the graph, but we can extend. So we got 1, 2, 3, 4, 5, 6. We can do our 7 here, come straight up, and we've extended this line, come straight across. 400, 500, 600 would be about there. So yeah, probably anywhere from, there's a range, 560 to 580. And you can have a range to answer that question. So that's extrapolation because you're extrapolating the data, and it's like, it's outside the graph. And if you want to remember an easy way to remember it, think about an exit. This kind of looks like the word exit, and exit is to leave, so extrapolation is data outside the graph. Okay, now that's just a basic rundown of the lesson. So the next 3 pages, so this one here on Jenna borrowing money, this one here you'll see an example. It's interpolation and extrapolation, and then these graphs, interpolation and extrapolation. So what you're going to do is that's your homework for this one. So I want you to do those three questions. Okay.